Good morning, champs. Today we're starting a brand new chapter in statics, trusses. Until now, we've worked with beams. Beams can resist axial forces, shear forces, and bending moments. Trusses are different. In a truss, every member carries only one type of internal force, an axial force. That force can either be tension or compression. Why is that possible? The answer lies in how we model the joints. In an ideal truss, every connection between members is treated as a frictionless pin. A pin can transmit forces, but it cannot transmit a moment. Because of that, bending moments cannot develop inside the members. Now imagine one individual member. If the forces at its two ends were not aligned with the member would rotate. The only way the member can remain in equilibrium is if the forces act exactly along its axis. That means every member carries only an axial force. There is no internal shear force and no internal bending moment. There is another important assumption. External loads are applied only at the joints. If a load were applied in the middle of a member, that member would immediately experience bending, and it would no longer behave like an ideal truss member. Now let's look at the two possible types of axial force. If the member is being pulled apart, it is in tension. Under tension, the member becomes longer. If the member is being pushed together, it is in compression. Under compression, the member becomes shorter. Throughout this series, we'll use one simple sign convention. At every joint, we'll assume that every unknown member force is in tension. That means we always draw the unknown forces pointing away from the joint. If our calculation gives a positive value, the member is indeed in tension. If the result is negative, the member is actually in compression. This approach keeps every joint analysis consistent and avoids guessing the force directions. To determine the member forces, we'll use the method of joints. Instead of analyzing the entire truss at once, we isolate a single joint. Because all forces meet at one point, we only need two equilibrium equations, horizontal equilibrium and vertical equilibrium. We never need a moment equation when analyzing an individual joint. The general procedure is always the same. First, determine the support reactions. Next, choose a joint with no more than two unknown member forces. Apply horizontal equilibrium and vertical equilibrium to solve for those forces. Then move to the next joint and repeat the process until every member force is known. Once you understand these ideas, solving trusses becomes a logical sequence of small equilibrium problems rather than one large complicated calculation. In the next video, we'll use exactly this method to solve our first complete truss step by step.